Okay, welcome along to the June 2017 paper 3, Foundations here, the last paper from June 2017, and it is a calculator paper. I'll go through all of the questions, showing exactly what I'm thinking for all of them, and hopefully it is useful for you guys. So without further ado, let's begin. Question 1, you've got complete disabler fractions, decimals, and percentages. Okay, so you've got the first one being a half. They've given it to you as 0.5, which is 50%. Now the second one, you've been given 0.27 as a decimal. Now, 0.27 as a fraction, well, we can write it as your number, which is 27, and because the 7, that is in the 100ths column, okay, so that 7, it is in the 100ths column, okay, your number is going to simply be 27 out of 100, okay, and that is it. So as a fraction, you've got 27 over 100. Okay, and you can't simplify it because you can't divide by a factor. There's no factor of 27 and 100. Now, as a percentage, well, anything out of 100 is by definition a percent, because percent means per 100. So that is going to be simply 27% is your answer. Okay, so 27%. Now, this one, we've got 4 over 5. Now, if we look at 4/5, 4/5, to get it to become a percentage, it's got to be out of 100. Now, to get from 5 to become 100, you can times by 20, do the same thing on the top. So equivalent fractions, 4 times 20 is equal to 80, so 80 out of 100, which is equal to 80%. Okay, so 4/5 as a percentage is 80%. And also, right, if we go and look at this, well, 80 out of 100, okay, 80 divided by 100 is also equal to 0.8. And you can use a calculator here. If you just type in 80 divided by 100, you would get 0.8, okay? So that is your answer for this one. Good. Okay, and then we've got the last one, which is 3%. Now, again, percent means it's going to be 3 out of 100. That is what 3% means. And again, you can put this into your calculators just to show you what I really mean is, if you weren't sure here, because 3% means 3 out of 100, you're literally doing 3 divided by 100, and you're going to see that is equal to 0.03. So as your decimal, we've got 0.03, and we've just seen it as a fraction. I've already put it here. Okay, 3 out of 100, so there we go. That is your fraction, 3 over 100. Check the mark scheme, no silly mistakes. No, we are all good. Okay, part B. It says, also apologies if you can hear a bit of a car noise. There's a lorry with its engine turned on and it's pretty noisy, so apologies if you can hear that, but hopefully it will go in a second. Part B, write 45% as a fraction in its simplest form. So again, percent means your number, 45 per 100, and you just got to go and divide through now by a common factor. And 45 and 100 are both factors. Sorry, you can divide them both by 5. So 45 divided by 5 gives you 9, and 100 divided by 5 gives you 20. So 9 over 20 is your answer. Okay, 9 over 20. There we go. And let's highlight the answer. There we go. Is that actually more clear to see? Let's just highlight it. There we go. Part C. Alan and Brian share a sum of money in a ratio 1:4. Okay, so you've got Alan to Brian in a ratio 1:4. So I'd always just straight away, I'm not even reading the question, make a note of this. You've got Alan to Brian, and they share money in a ratio 1:4. And it says, what fraction of the money does Alan receive? Now, a fraction is always out of the total amount. Well, if you've got 1 part, add 4 parts, that is a total of 5 parts in total. And Alan receives 1 part, so it's got to be 1/5. Okay, so that is it. 1/5 is your answer for this one. And there we go. Let's give that a highlight. Good. And that is the first question done. Question 2. We've got this. Corey invests £8,400 at simple interest, so not compound, at 12% per year. Work out the value of the investment after 3 years. So basically, right, you want to go and find 12% of your amount, which is 8,400, okay, and that's going to be for 1 year. Now in maths, if you find percent of something, you're just timesing them, okay, so you're doing 12% times this. Now 12% as a decimal, you can just go and write it as 0 0.12. If you times that by 8,400, okay, now that's going to give you 12% of this number. So calculator time, let's go and get it out. So we're doing 0.12 and we're timesing it by 8,400. Enter it. That is equal to £1,008. So that's going to move the calculator a bit more over here. So that's going to be equal to £1,008. Now this is how much interest you would get after 1 year. So let's just make a note of that. This is for, that's a pretty terrible arrow. This is for 1 year. The question is saying after 3 years, so you've got to go and now do 3 times that £1,008, okay, which is going to be equal to £3,024 here. Just be careful, the question is saying the value of the investment after 3 years. You've got to go and now add this on to what you start at. Okay, so the final value is going to be, you can say that the investment, okay, is going to be equal to 8,400, and you're adding on that 3,024, okay, and that's going to be equal to whatever it's equal to. So 8,400 add 3,024, and it is £11,424, and there we go. Okay, that should be your answer, and it is good. So simple interest, you just find the percent of the amount, so that's after 1 year, and you just times it by how many years you have, and that is it. If the question said how much interest did she earn, you would just put this as the answer, but the final value of the investment is what you earn plus your starting value. Question 3a, find the value of y. It's just saying that you're timesing 5 by itself 1, 2, 3, 4, 5, 6, 7. So the power here has got to be to the power of 7. Part B, it says find the value of z. So something times by itself gives you 196. So you can go and say that z must be equal to the square root of 196. Now, if you didn't know how to do this, use a calculator. Yeah, we can go and again get it out. Okay, you might know it's 14. If you weren't sure, just type in the square root of 196 and enter it. And it tells you, right, you get an answer of 14. But the question, as you can see, is asking for 2 solutions. But the thing is here, right, one of them is 14 because we know that 14 times 14 is going to give you 196. But also, if you do negative 14 and you times it by negative 14, well, if you multiply 2 negatives, you get a positive solution. So the answer is also going to be negative 14 as well. Question 4, expand and simplify. So just look at the first bracket first. So we've got 5 times x and then 5 by negative 2. 5 times x gives you 5x. 5 by negative 2 gives you minus 10. You've then got on a second bracket negative 2 times x and then negative 2 times by negative 4. Okay, so negative 2 times by x gives you minus 2x. You've then got negative 2 times by a negative 4. You're multiplying 2 negatives, you're going to get a positive 8 there. And now we are just collecting like terms. You've got a 5x, you've got a 5x, and you've got a negative 2x. You must include that negative there, that's really important. And you've also got a minus 10, and you've got a plus 8. Okay? So 5x take away 2x is going to simply give you 3x. And then you've got negative 10, add 8. So if you're not sure with this one, go on to a number line. Okay, you're beginning at minus 10, which is down here. You're adding 8. So 1, 2, 3, 4, 5, 6, 7, 8. So minus 10, minus 9, minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2. Okay, so minus 2 is where you get to if you add 8. So 3x take away 2 is your solution for this one. This one, you want to factorize fully, 10x squared plus 6x. First of all, if you look at your numbers 10 and 6, well, let's just go and consider the factors of 10 and the factors of 6. What can you multiply to give you 10, first of all? Well, you can do 10 times 1, and you can do 5 times 2. Really messily written, let's do that a little bit neater, because you can't even read it. So you can do 10 times 1, and you can go and do 2, and you can do times by 5. the 6, you can do 1 times 6, and you can also do 2 times 3. Now, the biggest factor here, because when you factorize, you want to put it into brackets, so you can take out a 2 is a factor of both 10 and 6, and is the biggest factor. So we're going to be taking out a 2 and a 2. So we can go and take out a 2, but also you've got an x squared and an x. You can take out a x and then open up a bracket and say, well, 2x times by what gives you 10x squared? Well, 2x times by 5x, okay, because 2 times 5 gives you 10, x times x gives you x squared, so altogether you get 10x squared, and then 2x times by a positive 3, okay, gives you 2x times by 3 gives you 6x. So we get 2x bracket 5x plus 3, okay, and that is your answer. This one, simplify x5 to the power of 2. Okay, this is a law of indices, which is if you've got a power to another power, you just times them together. Okay, so you're doing 5 times 2. So that's going to give you simply equal to x to the power of 10. And that is it. Okay. If you want to look at it, that's your answer. If you wanted to look at it in a more perhaps sort of detailed way, you could think to yourself that, well, you've got x to the 5 and you're timesing it by itself, because that's what squaring a number means, right? If you're squaring something, you're timesing this by itself twice. And we know also, another laws of indices, if you're timesing with the same base, you just go and add the powers. 5 and 5 gives you 10. So again, you just get x to the power of 10. Good. Question 5, find the value of 3a plus 2b when a equals to 16 and b is equal to 7. So we're just putting in these values here. So we've got 3. Sorry, that lorry is so noisy. It's really annoying. Sorry about that, guys. We've got 3 times by the a value, and the a value here, the a value is 16, so you just replace a with 16. So 3 times 16, and you are adding on to that 2 times your b value, and you can see that b is equal to 7, so 2 times 7. So 3 times 16 is going to give you 48, and then 2 times 7 gives you 14. Add them together, you're going to get 62. 4, 5, 8, so 62, and that is your answer. Good. Easy 2 marks. Now this question, if you're given a formula like this, where you've got kind of these letters and you're given this information here, this is something called SUVAT, okay? So this is something called SUVAT, S-U-V-A-T, and you need to know what the letters mean. Now, for the time being, just S, it stands for something called displacement, but just think about it as being distance for the time being, okay? Really, it means displacement, but at this level, we'll just think about it as being distance. Now, U stands for something called the initial velocity. So you're starting, velocity is a bit like speed. It's speed with direction, and it's just like your starting speed. V is your final velocity, and then A is your acceleration, and then T is your time. So now if we look at the question, we've got here's your formula, and to find the final velocity is what we're trying to find when the initial velocity is 2. So we can just go and say there that, well, we know that the initial velocity from over here is the letter U. So that is the letter U. We also know that the acceleration is 1.5. So the acceleration, which is going to be called, and we know that the acceleration is given by A. So that's going to be A. You could also write lowercase a for acceleration. In fact, I probably should have done that actually. That's a bit confusing. So acceleration, let's just go and write it as A. In fact, let's write all of these as lowercase. That was my mistake. That's fine. I should have left that. That's fine. So SUVAT. There we go. And then your time is 6 seconds. So time is T. So that's your letter. So if you know what these stand for, these letters, so you need to know that initial velocity, it is U, as you can see from SUVAT. Acceleration is A. Time is T. You need to know this here. It's quite important. And you're trying to find the final velocity, which is V. Okay, so you're trying to find V. So simply, you just whack it into this formula, and you say that V is equal to U, which is 2, plus the acceleration, which is 1.5, you're timesing it by the time, which is 6 seconds. So v is equal to 2 plus 1.5 times by 6 is going to give you 9, I think. Let's double check it. 1.5 times 6 gives you 9. Good. So you've just got 2 plus 9, which simply gives you 11. And that should be it. That is it. Good. 11. Perfect. Question C, make D the subject of the formula. So currently C is the subject, it's the thing on its own by itself. To get D to be the subject, well, this means 7 times D. You've got to go and divide both sides through by 7. Okay, so it's going to become C divided by 7 equals to D. Because if you divide this by 7, the 7s will cancel, then you can divide this one by 7. Another way of writing it, you could write it like this. Okay, so if you divide both sides by 7, you divide by 7, and you divide by 7. Then these two, they cancel out, because the opposite of timesing and dividing, they cancel. So you're just left over with D on its own over here, D being equal to C divided by 7. And that's your answer, okay? And you can write it with the D going first. They mean exactly the same thing. That is your answer. Good. Question 6a. Henry puts 8 counters into a bag. Okay, nice. Each counter has a different whole number on it between 1 and 8. He picks a counter at random from the bag and the number is noted. Choose from the words in the box to complete the sentence. Okay, so let's just visualize what is going on here. You've literally got 8 counters, so 1, 2, 3, 4, 5, 6, 7, 8, numbered from 1 to 8. So 1, 2, 3, 4, 5, 6, 7, and then 8. It is something that he picks a number less than 9. Well, it must be certain, because all of these numbers here are less than 9. So the first one is definitely going to be, it is certain. Okay. There we go. And in part I, it is what that he picks an odd number. Well, the odd numbers we need to know. Sorry, again, if you just joined, I've got a lorry outside my flat and it's put its engine on for the last hour or so. It's really noisy. Apologies about that. But we'll carry on. Hopefully you can't hear it too much. Sorry, the odd numbers are 1, 3, 5, 7, 11, so on and so forth. So from our list here, you can see you've got 1 is odd, 3 is odd, 5 is odd, and 7 is odd. So you've got 4 odd numbers out of a total of 8 numbers in total. So you've got 4 over 8. And 4 over 8, okay, if you sort of simplify down a fraction by dividing it by 2 and dividing it by 2, is the same thing. Sorry, dividing it by 4, sorry. We can divide by 4, divide it by 4, and divide it by 4. You get 1 over 2. So that is a half chance, which is evens. So you can go and put evens into this one here, and that is your answer. Part B. The Venn diagram shows the number of students who passed their examinations of French, F, and those who passed their examination in Maths, M. The number of students who did not pass is given by B. Find the value of B if the total number of students is 55. So you know that this, add this, add this, add the B will give you 55. So let's make a note of that. So 18, add 21, add 10, add that one will give you 55. So if we go and add these ones here together, that's going to give you 39, 49. So 49, add B will give you 55. So B must be equal to 6 because 49 add 6 gives you 55. So B must be 6. Let's check that on the mark scheme. I've lost where we are. Where are we up to? Yeah, it looks good to me. This one of the 55 students is selected at random. What is the probability that the student passed both French and mathematics? So that's looking at the both bit is in the middle. Out of the whole total, so it's going to be 21 over the total, which is 55, and that's simply your answer. Part triple I, passed exactly one of these two subjects. So that's just got to be, right, only one. You're looking at like either just this part of the Venn diagram, okay, or this part, okay. So you do not include this number here. So it's going to be like these people here, these people just passed French, and these people just passed maths. Okay, so in total, it's going to be 18, add 10. So that's 28 people who pass only one subject. So 28 over, again, the total, which is 55. You could simplify your fraction, but you don't need to. That is your answer. That is absolutely fine. Okay? Good. Question 7. Is this Hardeep buys 11 identical shirts, 11 shirts and 24 ties for this much here. The cost of a shirt is this. Find the cost of a tie. Okay, so we know that one shirt has a cost of £15. I'm writing it as a ratio, 65 pence, and he bought 11 of the shirts. So to get from 1 to 11, what are you timesing by? 11. So you're upscaling by 11. Do the same thing over here. So you can do 15.65 and times it by 11. Let's just use a calculator because we can for this paper. So we're just doing 15.65 and times that by 11. Enter it. What do we get? We get 172.15. So we get 100. Oh, I want it to be in red. We get 172.15. Now, the whole cost is 403.51. We take away the cost of the 11 shirts. Okay, that's going to be a good place to go next. We can go and do the 403.51. Take away the 172.15, which is going to leave us with how much left? So 403.51, take away 172.15, that gives you this 231.36. So you now know that the 24 ties must be worth those. So you know that you've got to share this between 24 ties, right? But you want the cost of one tie. So to get one, you can just go and divide this number, divide this by 24, and that's going to give you an answer of one tie. So divide that by 24. That's going to give you this. So 9.64. Hopefully I've made no blunders there. Looks good. So that's going to be £9.64. And that is your answer. Okay, so hopefully I've checked the mark scheme. That's going to be good. But £9.64 is correct. I think when we're looking at this question, yeah, good. All good. Okay, question 8. Harry needs to buy dollars to go on holiday. He can buy $50 for £40. How much will $720 cost at the same rate? So again, a bit of a ratio question here. So we've got $50 to £40, and he has this much dollars. So we're just going to be upscaling again. So we've got $720. Now to get from here up to here, we can go and do 720 and divide it by 50. So, or the lorry stops, that is lovely. So we can go and do 720 divide it by 50. That gives you this. So if you times 50 by 14.4, you're going to be upscaling. So 50, and if you times this number, times this by 14.4, that's how you get from there to there. Do the same thing over here. Do £40 and times it by 14.4. So times 40, times it by 14.4, enter it, and we get £576. And hopefully that is our answer. It is, so good. 576. This is what you wanted. There we go. Good. Let's leave the calculator over here. B. Tony returns from holiday with these notes. So these notes in dollars, number of notes here. The exchange rate is this. Okay, nice. Work out how much he will get in total when he changes these notes. Well, first of all, and you want to give the answer in pounds, as you can see. First of all, just work out how much money he's going to have in total in dollars from here. So if you've got 2 lots of 50, you're just here timesing your numbers together. That's going to give you 100 of these. 4 times 20 is going to give you $80. 10 times 9 is going to give you $90. 5 times 12 is going to give you 60. Now in total, if you add all of those together, 180, 270, 330, you're going to be getting $330. Let me just double check that. So 180, add 90, add 60. Good. Again, and we've been given this ratio over here to use, which is that £1 is the same thing in dollars as £1.17 as the ratio. We know we've got over here, we've got 330. And to get from this number to this number, just do 330 divided by 1.17. So let's go and do that over here. Let's go and do 330 divided by 1.17, enter it. You're going to get this decimal, okay, which looks horrible, but that's fine. Yeah, so we're timesing up. If you times 1.17 and you times it through by 282.05, blah, blah, you're going to get to 330. Do the same thing over here. Times this number by 282.05, dot, dot, dot. So actually, right, if you just go and do 1 times this number, if you round it, okay, you're going to be getting, let's check the answer here as well, 8b, you're just going to be getting, well, £282. It's not asking me to round anything here. It just says, work out how much he will gain in total. Let me change these notes. There's no rounding here, so you could put, that's fine. I'm going to leave it like that. So my answer is going to be 282 pounds, okay, and that's to the nearest whole number, and that's fine. Good. Check the mark scheme. We are all good. Perfect. Okay. Question 9a. We've got this. Round this number to 2 decimal places. So here's your decimal place. Your second one, the 3 is the first. The 0 is your second. Now, if your number to the right, okay, is 5 or more, then you round up. If your number to the right is 4 or less, then you round down. So because the number to the right of the 0, the second decimal place, is a 6, which is bigger than 5, you round this 0 up to a 1, and you're going to be getting 7.31. Okay, that's your answer. This one here, round each number correct to 3 significant figures. Now, your significant figures are your first non-zero numbers. So for this one, right, this 4 is your first significant figure. That's your second. That's your third. So the 8 here is your third significant figure. And then you round it the same way using the stuff up here. So your number to the right of the 8 is a 2, which is less than 4. So you keep this number here as a 8. So it's going to be 4, 0, 8. And then your numbers afterwards become zeros. So 0, 0, 0. So 408 and then 0, 0, 0, 1,000. And let's get rid of that comma because it might look a bit confusing. Let's get rid of all of these actually and just say we have 408, 0, 0, 0. Good. This one here, a bit more interesting. So these zeros, you don't count as significant figures because it's your first number that isn't a 0. So this 6 is your first significant figure. That's your second. This is your third significant figure. Now, again, you look to your number to the right of this 3, which is a 7, which is bigger than 5. So you round the 3 up to a 4. So it's going to be 0.0061 and then a 4. These numbers here would become zeros, but after the decimal place, you don't need to write the zeros there. So it's just simply going to be equal to 0.00614, and that is our answer. Okay, good. Question 10. Write down the second and third terms of the following sequences. So rule to get the next term subtracts 4 from the previous term. Okay, so we're just going to be taking away 4. So 19 take away 4 is going to give you 15. 15 take away 4 is going to give you 11. That's it. Next one. Multiply the previous term by 5 and then add 3. Okay, so the first term is 7. So we're going to do 7 times it by 5. Okay, so 7 times 5 and then add 3. So that's going to give you 35. Add 3, which gives you 38. Good. So 38, and then same thing again. We take this term, we multiply it by 5, add 3. So we're going to be doing 38 times it by 5, add 3. 38 times 5 is going to be equal to 190. 190, add 3, gives you 193. Let's check the mark scheme. We are good. Perfect. Here are the first 4 terms of another sequence, 5, 9, 13, 17. Write an expression for the nth term of the sequence. Okay, so it's the nth term. I'm going to kind of write the sequence again over here because I like to go through it in a particular way. So we've got 5, we've then got 9, we've then got 13, we've then got 17. Now to get from term to term here, you are simply adding 4. So you're adding 4 here. 9 to 13, you're adding 4. 13 to 17, you're adding 4. Now to show a plus 4 increase in terms of n, it's just your 4 times table, you would write it as 4n. Okay, so you're going to write this as 4n, and 4n is your 4 times table, so 4, 8, 12, and then 16. And then to get from 4 to 5, you add 1, 8 to 9, you add 1, 12 to 13, you add 1, you add 1. So to all of these terms here, you're just simply adding on a 1. So overall, you've got the 4n, okay, and you're adding on the 1. So you do get 4n plus 1, and that's your answer. And you can check this. Let's go and check maybe the third term. The third term is when your n value, because like this is when n equals 1, your first term, n equals 2, your second term, n equals 3, n equals 4. When n is equal to 3, put it into this. What do you get? So if we check it over here, we check our answer. So it's going to be 4 times n equals 3, add 1 does give you 13, which is the third term. Okay, so we've checked our answer. I'm definitely happy with this. Good. 11A. Grapes cost £2 per kilogram. Okay, and then calculate the cost of 380 grams of grapes. Again, another ratio question. They're going ratio crazy. What I noticed here is you've got kilograms here and you've got grams down here. You need to know that in a kilogram, in 1 kilo, that's equivalent to 1,000 grams. You want to get things into the same unit, okay? So the cost is £2 per kilogram, so per 1,000 grams of grapes. You've been given 380 grams of grapes. Now to get from 1,000 to 380, if you go and do 380 and divide it by 1,000, that is what you're going to be upscaling by. So if we get our calculator, and if you type in 380, and then you divide it by 1,000, 0.38, you might have already noticed that, but there you go, 0.38. Perfect. That's going to give you, so if you times 1,000 by 0.38, so 1,000 times by this, you get 380. Now, of course, ratio, do the same thing on both sides. We're going to times through by 0.38. So we can now go and do 2 times 0.38, again, with our calculator. Don't know why I got rid of it. That was pretty silly. But if we go and do £2 times 0.38, you get this 0.76, which is your answer. Okay, so that's it. £0 and 76 pence. There we go. So 0.76. Check the mark scheme. 11A. Perfect. We are good to move on. Question B. Ruth buys 19 identical tickets for this price here. Estimate. Right. This is a key word here. Estimate the cost of 1 ticket. So you know, right, there's 19 tickets and you buy it for this much. Now, this is really, really important. If you estimate something, okay, at GCSE maths, you round. So you round to 1 significant figure. Okay? That's really important. Now, if we look at 19, okay, if we look at the number 19, now your first significant figure is that 1. And again, this 9, okay, is going to round, make a note of this up here. Your number to the right, if that is 5 or more, you round up, and 4 or less, you round down. Okay, and because 9 is bigger than 5, you're going to round this one up to a 2. Okay, so this becomes a 2, and you replace this number with a 0, similar to the previous questions we looked at on significant figures. If we look at the number now, 280.25, okay, and we look at this just means kind of approximately equal to. Now, your first significant figure here is this 2, and again, the 8 is bigger than 5, so the 2 is rounded up to a 3, becomes a 3, and then the rest of your numbers just become zeros. So it's going to be 300.00, which is just the same thing as 300. So I've estimated, it looks a bit weird, but right, if you round 19 to one significant figure, you get 20. If you round this to one significant figure, you get 300. Now, if 19 ties cost this much to get, if 19 tickets cost this much to get one ticket, you can just go and simply now go and do the total cost of them, which is £300 now, which you've estimated, and you can simply divide it by 20, and that's going to give you 15, isn't it? So that gives you an answer of 15. Let me just double check that. 300 divided by 20 gives you 15. So, sorry, it's not very neat, is it? It gives you £15 per tie. Okay, question 12 is this. The shape is formed by a rectangle and measuring. Okay, so you can see on the diagram, you've got this kind of shape here, and it's formed by a rectangle measuring 12 by 15, as you can see, with a rectangle of length 7.4 being removed. Okay, cool. Work out the perimeter of the shape. So the perimeter is the path around the outside of your shape. So this, add together this, add this, okay, add this, add this, add this, add this, add this. Now, you know this length already. You know this length must be the same as this length. So that's got to also be equal to 12 centimeters. You know this length is 6.3, that's 7.4. This must also be 7.4 because these are the same thing. So that must be 7.4 also cm. And you're just missing now this part over here. Now, to get this part here, if the total thing over here is 15, so if we sort of visualize this over here, if the total thing is 15, this bit, if you removed this one over here, so if you kind of got rid of this one and got rid of this one, so if we kind of know that, like, bam, bam, this is equal to 6.3, and this is equal to 5.8, and the whole thing, right, is equal to 15. To get just this part, okay, this part here, which is this part here, you just do 15, and you take away this part and this part. So we can go and do 15, and we can go and take away 5.8 and take away 6.3, and that's going to be equal to whatever it's equal to. 5.8 take away 6.3, which is 2.9. So this here must be 2.9 centimeters. You've got to make sure you've got the length of every single part of that shape. That's pretty important here. Now, to get the perimeter, we just go and add it all together. So we just simply go and add everything together now. So it's going to be, if we start with this length, keep it in order, we've got 15. We're going to add 12 to it, and then add 6.3, add 7.4, 2.9, another 7.4, add 5.8, and then add that 12. That will give you your answer. So let's just go and add this up. 15, add 12, add 6.3, add 7.4, add 2.9, 7.4, 5.8, add 12. You should be getting, hopefully, question 12, 68.8, which is correct. Good. 68.8 cm. And let's just go and put it down here. So 68.8, and there we go. That is it. Question 13 is bounds. So the mass tons of a girder is 12.7 correct to 1 decimal place. Complete the error interval for the mass. So the way that you approach these is we go and draw a bit of a line. The middle number is the number that you're looking at, which is 12.7. Okay, and we're going to 1 dp. So your number is 12.7. Now, you just, to get the kind of the upper part and the lower part, you just go one above the 7 and one below the 7. So you're going to be getting 12.8 up here, and 12.6 down here. And then you want to go and get the parts in between each of those there. So halfway between 12.6 and 12.7 is 12.65. And over here, it's going to be 12.75. That's in between 12.7 and 12.8. And these values here are your lower bound and your upper bound. So it's going to be 12.65 and 12.75. Let's just check it makes sense. Okay, if you round this number to one decimal place and this to one decimal place doesn't make sense, well, your first decimal place here is the 6. The 5 would round up to a 7, so you would get 12.7. Good. Anything smaller, like 12.64, okay, this 4 would actually keep this as a 6, so you wouldn't get 12.7, so this is definitely correct. Now, this one over here is a bit more interesting. If you actually round this to one decimal place, that 7 would become an 8, because the 5 would make it become an 8. But this sign here means you do not include this number. You go just below it. So really, your number here is going to be 12.749999, so on and so forth. So because this means you go just below this number, so if that would be this number here, and your first decimal place here, well, the 4 would keep it as a 7, which is what you want. Okay, so it does make sense. Now part B, it says the length of a piece of wood is given as 8 meters, correct to the nearest 1 meter. Okay, and the length of a rod is 8.5 meters, correct to one decimal place. Show that the piece of wood could be longer. Okay, so this is the wood and this is the rod. The piece of wood could be longer than the piece of metal rod. Again, just go and draw out your error intervals first of all. 100%. So if we look at the bit of wood first of all, so let's do it in red. If we look at the wood, okay, again, get your line, your middle, your value is going to be the 8, and the nearest 1, this means that the nearest 1 meter, your upper part, you just go and add 1, your lower part, you take away 1, so it's going to be 9, and then 7, and then in between that is going to be your bound, so it's going to be 7.5 and then 8.5. So for the wood, okay, for the wood, it's got to be bigger than or equal to 7.5 but less than 8.5. This is your error interval. Check it makes sense. If you round 7.5 to 1 meter, you do get 8. Okay, instead of wood, really, let's go and write 8 in there. That looks a little bit weird. So 8 in there. And again, this means you go just below 8.5, so like 8.4999. That would get you 8 to the nearest meter. And then for the rod, let's do a very similar thing. So let's go and do the rod down here. Again, get your number line out, and your middle number is what you're looking after, which is 8.5. And you're going to one decimal place, which is this part here. And if you go one above this and one below this, you're going to be getting 8.6 and then 8.4, and you can go in the middle of these now. So it's going to be in the middle, it's going to be 8.55, and then it's going to be 8.45. So if your number is 8.5, it's going to be bigger than or equal to this, but less than 8.55. Check it makes sense. If you round 8.45 to one decimal place, you do get 8.5. Anything smaller, you wouldn't get 8.5. And then the biggest number that's going to work just below this number, you would indeed get back to this here. Now the question is saying, show that the piece of wood, so this, it could be longer than the rod. Well, if you use, let's highlight it in blue. If you use the upper bound, okay, sorry, if you go and use the upper bound for the wood, so we're going to use 8.5, so that's not a great colour, is it? It's a bit sharp. So if we use the 8.5 for the wood, okay, and we use the lower bound for the rod, okay, you can see that 8.5 is clearly bigger than 8.45. So we call this the upper bound, the biggest it can be. We call this the lower bound, the smallest it can be. Okay, so it's just saying, because on the face of it, right, 8.5 is bigger than 8, but if you actually use the upper bound of 8.5 for the wood and the lower bound of 8.45 for the rod, well then the wood is bigger. The wood is bigger than the rod. Okay, nice question. Nice question. Question 14, we've got this. Triangle A and triangle B are drawn on the coordinate grid. Translate triangle A by the vector 3, -5. Now the way that these vectors simply work is as the following. The top number is horizontal movement, okay, and to the right is positive, to the left is negative, and the bottom number is vertical movement, and upwards is plus, downwards is minus. So what you're going to do here is you look at triangle A, you choose a point, okay, and then we consider this. So we're going 3 across positively, so that would be 1, 2, 3, and then down by 5, 1, 2, 3, 4, 5. So that point would go down to here. You then take another point and you apply the same thing. So you're going 3 across again, 1, 2, 3, and down by 5, 1, 2, 3, 4, 5, which is this point down here. You then use the final point and you go again 3 across, 1, 2, 3, down by 5, 1, 2, 3, 4, 5, which is this point over here. Okay, and then you just join it all together. Bam, bam. That's not very good, is it? Not very neat. We just go down through here. Bam, bam, bam. If you want to be really fancy, when you translate a shape, you write a little dash up here. This is fine. That's your answer. Part B, I can't really do it because to describe the single transformation that gets A to B, it's going to be a rotation. So you're going to be what you need here is tracing paper. And if you were to rotate this, you would see that if you rotate it, I can't show you this, unfortunately, but I'm just going to have to type it up for you guys. You need tracing paper, but if you rotate, if you rotate the shape about the center 0, 0, 90 degrees clockwise, okay, you would go from shape A to shape B. So basically, right, if you put tracing paper over A, okay, so you got your paper, you drew this out, you then put your pencil on the point 0, 0 here, and then you span the tracing paper around a quarter turn, which is 90 degrees, so you turned it 90 degrees, okay, you would get from here to here. This is the only question that I can't really show you on these videos. Okay, but anyway, we're going to move on to question 15, which is this. Students at a school must choose from one subject from option 1, which you can see down here, and option 2, as you can see down here. The subjects are given in the table. Okay, nice. Work out the percentage of all the subject combinations which have exactly one language. Let's just look at all of the combinations. So you could, for example, go for French and Spanish, French and geography, French and history. That's one set of combinations here. So let's kind of make a note of all of these here. So you could go French, and then you could go Spanish, you could go French, and you could go geography, and you could go French, and you could go history. Okay? You could also go and do art and Spanish, art, geography, art, and history. So you could go and do also, let's make a bit of a dash down here. Keep it all nice and organised. You could also go and do art, and then Spanish, art, geography, art, and history. Okay? We're looking at all the combinations here. You could also then go and do music with Spanish, music, geography, music, history. So S, MG, and H. Last but not least, you've got economics. So you've got economics with Spanish, economics with geography, economics with history. So you've got E with Spanish, E with geography, and E with history. Now, what you're trying to find, you're trying to find the percentage with exactly one language. So out of all of these here, which have exactly one language. So if we look at the first one, well, French and Spanish, no, that's 2 languages. French and geography, this is good. You would include this. French and history, that's 1 language. French is a language. Art and Spanish, that's 1 language. Art and geography, that's no languages. Art and history, no. You've then got maths and Spanish. Spanish is a language. Math, geography, math, history, no. You've then got economics and Spanish, no, and then no. So you can say that the probability, capital P, of getting one and only one language, you don't need to write this, but I'm just being a little bit fancy about this, is going to be equal to, you can see you've got 1, 2, 3, 4, 5 successful outcomes out of a total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You've got 12 outcomes there. Now to get it, that's fine, but you want it as a percentage, you just simply multiply this by 100. Okay, so actually, right, really, we shouldn't write this here, because now it's not, oh no, we can write that, what am I doing? That's fine. But just now whack this into your calculator. So 5 divided by 12 times by 100, and you should be getting sort of 41.6 recurring percent, and hopefully 15. Yeah, that's fine. Okay, so if I round it, we can also just go and say, look, 41.6%. That is your answer. There we go. Good. Question 16, we've got a scatter diagram, and it says the owner of a tourist attraction records the amount of rainfall, as you can see down here, in millimeters, and the number of visitors over here each day. The results of the 10 days are shown in a scatter diagram. Circle the outlier. Now, the outlier just is the point that doesn't match the overall trend of the data. And you can see roughly here, you've got a negative correlation with these points here, and this point doesn't fit the trend. So this point is the outlier. Okay, let's do it a little bit thicker. So this is the outlier. Okay. Now, the owner claims that he would expect 320 visitors on a day with 2 millimeters of rainfall. Does the scatter diagram support this statement? Explain how you made your decision. To do this, right, you need to go and draw in a line of best fit. So line of best fit is a line that roughly shows the trend of the data with an even number of points roughly on each side, and you exclude the outlier. So this line here shows the overall trend of the data. Now it's saying when you've got 2 millimeters of rainfall, they're saying you would expect 320. Let's go and check this. So when you have 2 millimeters, we're going to go and look at this point over here of rainfall. So we go up from that 2, we go up to here, and then we go across over to here. And to me, right, this looks like we're looking at about, I would say, 230-ish. So about 230. Okay, depending on how you draw your line, it will vary. Now, 230 visitors is nowhere near 320. So the scatter diagram does not support a statement. Okay, when you have 2 millimeters of rainfall, we would expect to have about 230 visitors. So we can go and say that 230 is much less than 320. So the scatter graph does not support the statement. Lovely. And that lorry is turned on again. So there's a lorry outside my flat. It keeps, I don't know what it's doing, but it's being very noisy. Apologies if you can hear it. Part II, it says, explain why the scatter diagram should not be used to estimate the number of visitors on a day with 9 millimeters of rainfall. Now, if we look at our rainfall down here, it goes along here. This is a classic exam question, right? 9 millimeters is here. This is outside of the range of data. Okay, we're going from 0. The last point is between 5 and 6. 9 is way outside the data set. Okay, so you just say that that 9 is outside of the data set. It's a classic exam question. They always ask questions like that. Okay, so exam practice. Right, you can see we're going kind of between. The first point is at 0. The last point is kind of around 5 and 6. 9 is nowhere near the data set. Okay. Part B, the pie chart summarizes information about the visitors to a tourist attraction on a different day. So you've got children and adults. Explain why the pie chart cannot be used to work out how many adults visited on a day. There are no numbers, okay? Because, if you're trying to work out how many adults there are, there's no numerical data. I don't know how many children there are. If you could, you could measure the angles here, okay, and then you could work out proportions, but without any numerical data, you can't work out how many adults there are going to be. You can just go and say that you don't know how many people there are. Okay? No numerical data. Okay, good. There we go. On to the next question, which is this. The scale on a map is 1 centimeter represents 25 meters. The length of path is 240. Okay, so let's make a bit of a note of this. 1 centimeter is 25. Again, ratio. The length of a path is 240. Work out the length in centimeters of the path on the map. Write things down. So you've got a map. Let's do it in red, and let's go over here. You've got the map ratio to the scale in real life, okay, is 1 centimeter on the map is equivalent to 25 meters. Again, I think this is about the 4th time now we've dealt with ratio, so it's, you know, you can see really it's the same things over and over again. The length of the path in actual real life is 240 meters, so we're going from 25 to 240 meters. What are you upscaling by to get from 25 to 240? Again, get your calculator out, and let's do 240 and then divide that by 25, and that's going to give you this, which is not too bad, 9.6. So if you multiply 25 and you times that by 9.6, you get to 240. So you do the same thing over here. You do 1 times 9.6. 1 times 9.6, of course, just gives you 9.6 cm. That's your answer. So the length in centimeters, there we go, cm, of the path on the map is 9.6. Yeah, there we go. And that is your answer, 9.6. 17A, double check it. I think we should be good. We are all good in the hood. Perfect. Part II. The scale 1 cm represented to 25 meters can be written in the form 1 to k. Find the value of k. This looks really daunting. It isn't. Okay, write down again. It's the same ratio, right? You've got the map to the real life is 1 cm to 25 meters. Now, the thing is, to get this into the form 1 to k, it just means the first number has to be a 1, which it already is, and you've got to work out the value of the second number. Now, because the units here are different, you've got cm and meters, you've got to get them into the same unit to compare it. And we know that in 1 meter, you've got 1 meter is the same thing as 100 centimeters. So that means that 25 meters must be equal to 2,500 cm, because you're just timesing through by 100. Okay, so that's what you're doing over here. So that means, back to over here, we can write 1 centimeter is the same thing in the same units as 2,500 centimeters. So the first number is a 1, The second number, k, is just what number this is, which is simply going to be 2,500. But really important, guys, you get the same unit. Okay, good. Question number B. Loci question. Lovely. The scale drawing represents a park, and the scale is 1 centimeters is 25 meters. I think that's the same ratio. Make a note of it. We've got 1 cm to 25 meters. It says a new play area must be no more than 150 meters from point B. So if we just look at this one first of all, point B is here, and 150 meters, again, ratio again, we are scaling up by, we're timesing up through here by 6. So we're going to go and times up this number again by 6. 1 times 6 gives you 6 centimeters. So this is where you're going to get your compass out, okay? And we're going to be measuring, right, 6 centimeters from B. You're going to get like an arc around here. So let's go and take our compass, which is here, and you want to make sure that it has a length of 6 centimeters. For me, I can just literally, I can change the length of it quite easily. So if you look at you can see that's going to be 17.3. We want it to be 6, so that's good. Okay, so this is now 6 centimeters from the point to the pen. I put this on point B, okay, and I go and draw in an arc around here. There we go. So this one is done. Okay, so every single point on this arc here is 6 centimeters away from point B. That's 6 centimeters to B. That's 6 centimeters to this point here. And it's got to be no more than 150 from B. So it's got to be within this part over here. This one, closer to AD than to CD. Now, that's saying it's got to be closer to the line AD than to this line is CD. So you want to basically cut this in half using a angle bisector, and you want everything over here because that's going to be closer to AD. But of course, you've got to do this using constructions. So this is recognizing you're going to be doing a angle bisector. Okay, again, exam practice, you're going to just spot these really, really quickly. So you're going to be cutting this point here in half. To do that, again, you need your compass. We're going to spin this round. We're going to put it over here, and you go and draw in 2 arcs, so like one there, and you need to spin it around again, and you do a second one over there. You keep the compass the same distance, don't change it at all. And then we're going to draw in another 2 arcs from here, bam, and then we're going to move this, put it onto the point over here. We're going to spin it and draw in another one over here. Okay, good. And now, if you go from point D and you go through where these 2 arcs cross, okay, you have you've exactly cut the angle D in half. And closer to AD is going to now be everything over here. This is all closer to AD. This is all further away from AD. Now, when you do this, it might look a little bit different because I've snipped this onto a document. The proportions will be out a little bit. So yours might look a little bit different, but the idea is still the same. Now, all we've got to go and do is shade the region where the play area can be positioned. So we know for the first one, it's got to be no more than 150. It's got to be kind of within this part here, and it's got to be closer to AD. So it's got to be everything within this part of our park. Okay, just this part here. Yeah, and that is my answer. I quite like the loci questions. They're always quite nice to do. Good. Question 18. Question 18, we've got this. Right, sorry. A village has a population of 4,200. Population and a population density. Wow, I haven't looked at these kind of questions in a long time. Of 700 people per kilometre squared. An estate is built next to the village, and the estate has an area of this, and a population density of this, and this. Right, there's loads of words here, but they always look more complicated than what they are. We're just going to break it down and then work out the population density of the village. Right, just do one thing at a time. So let's consider the village first of all. So I'm just going to go and make a note of the village. Okay, just do one thing at a time. I'm not even reading the question really. I'm just going to work out what I can work out. Now you do need to know, crikey, population density. I haven't looked at this in years, but the formula for population density, it just means like how many people are in like a certain area. That's what it means. Is equal to the number of people, and you divide that by the area. Okay, there we go. Hopefully I've got that formula correct. I haven't used this in a long time. I'm pretty sure that is correct. So for the village, right, we know, and actually I'm just going to go and abbreviate these. I'm going to go and write the population. I'm going to go and write it as just P. Number of people, I'm going to just abbreviate it to be N, and area to be A. Okay. For the village, you know that the population is this, so we can go and say that P. Sorry, no. I've called, right, number of people, I've called it N. So, right, the number of people, okay, N is equal to 4,200. And you know that the population density is this. So, P, I've called population density. P is equal to 700. There we go. Okay, so right, I've just called population density, I've called it P, I've called the number of people N, and area. Hopefully that's clear enough. Okay. Now, if I've got N and I've got P, I can go and work out the area, and that's definitely going to be useful at some point. Okay. Actually, just to make it clearer for you guys, I'm going to go and put the formula into a triangle over here. Okay, that's always a good thing to do. So I'm just going to go and put this information here into my triangle. So population density P is the number of people over the area. So to get the area over here, okay, I can go and do area. It's going to be number of people divided by the population density. So that's going to be A is N divided by P. So the A is going to be equal to 4,200, and then divide that by 700. So the area must be equal to whatever that's equal to, divided by 700, which is 6. Okay, and we're looking at the unit for area here is going to be kilometers squared. So area is going to be kilometers and then squared. Okay, cool. That's for the village. Let's now go consider the estate over here. And let's look at this one, the estate. The estate has an area, so has an area of 2 kilometers squared and a population density, so P, of 800 people per kilometer squared. Okay, so you've got A, you've got P. What can you work out here? You can work out the number of people. Okay, N. That's going to be equal to P times A. So you can go and just times these together. You can do 2 times 800. So N is going to be equal to 1,600. Okay, now I've got everything I could possibly want. I've got N for the village, I've got P for the village, and I've got A for the village. I've got A for the estate, I've got the population density, and I've got the number of people. Let's just go and add some units here, right? Just to make it clear, this N is 4,200 people. That population density is this many people per kilometers squared. In fact, I think that's making it more confusing. Let's just ignore that for the time being. What is the question asking? The question is asking work out the population density for the village and the estate together. So now all we are doing is we're saying the population density, okay, it's going to do it in blue. So P is going to be equal to the number of people in total. So that's going to be 1,600 add 4,200. So 4,200 add 1,600. And we're going to be dividing by the area, because it's the village and the estate. So you're doing village and the estate. The total area is going to be 6 kilometers squared add 2 kilometers squared. Sorry, I'm just writing in units there. 2 kilometers squared. So we can go and do 6 add 2, and then we're just going to simplify this a little bit. So the population density is going to be equal to 5,800 divided by 8, and that's going to give you your answer, which is equal to 725. And I believe that looks pretty good to me. Yeah, that's my answer. So 700, let's zoom out a little bit, 725. There we go. So to be honest, like with these questions here, I didn't even really read what the question was asking for. I'm just like using my formula, and you just work out what you can work out, and then usually it begins to unfold. Okay. Question 19. Interesting question by looking at it. You got this. The numbers have these properties. Both numbers are bigger than 7, so that one's probably quite explanatory. They're going to be bigger than 6, so like 7, 8, 9, 10, 11, so on and so forth. The highest common factor is 6. So the biggest number that goes into both numbers is 6, and the lowest common multiple of the numbers is 60. Find the two numbers. Now, if we consider the number 60 for this, okay, and we consider the factors of 60, which seems a bit strange because it tells you that the lowest common multiple is 60, and usually like you write up the times tables, but we know that the biggest factor has to be 6, and we're trying to find two numbers here that are going to work to give us these three statements. And if we consider the factors of 60, we're going to get the factors where, and we can choose two numbers where the highest common factor is going to be 6. Okay, so to make 60, you can do 1 times 60, you can do 2 times 30, you can do 3 times 20, you can do 4 times 15, you can do 4 times 15, you can do 5 times 12, you can do 6 times by 10, Sorry, it's getting a bit messy already. You can't do 7, you can't do 8, you can't do 9. We've gone back to 10 again. So these are all the factors. So these are all of the factors of 60. Now the numbers have got to be bigger than 6, so you can't include here. You can't have 1, you can't have 6, it's got to be bigger than 6, you can't have 2, you can't have 3, you can't have 4, you can't have 5. So we're left with, at the moment, we're left with 12, 60, 30, 20, and 10, and 15. Now, the highest common factor has got to be... Sorry, the important thing here is, right, the important thing here is all of these numbers here can get into 60. Like, you can do 12 times 5 will give you 60. 60 goes into 60 once. 30 goes into 60 twice. So this is going to work for the third one, but the highest common factor must be 6. Now 6 can't go into 10 or 15, 100%, so it can't be this, and it can't be this one. It can't be 20 also, you can't get 6 into 20. So it's either going to be 10, 60 or 30. Now, if we use the numbers 30 and 60, for example, well, the highest common factor here would actually be 30. So that's not going to work. If we use, let's go and try 12 and 30. Okay. Well, actually, yeah, the highest common factor here is 6. The biggest number that goes into 12 and 30 is 6. And the lowest common multiple is going to be 30. Let's prove it. So these are the answers, right? 12 and 30. Okay, we're going to go and double check the mark scheme. 19. Yeah, good. Let's check it. Let's go and check our work. If we look at the number 12 and the number 30, 12, what can you times to give you 12? You can do 1 times 12, you can do 2 times 6, and you can do 3, and you can times it by 4, and that's it. For 30, you can do 1 times 30, you can do 2 by 15, you can do 3 times 10, you can do 5 times 6, 8, 9, 10, you can do 10 times 3, which we already got. So there we go. You can see here that the biggest factor of these is a 6, is the biggest number in both of your lists. So this one is satisfied, good. And the lowest common multiple, well, if you write out the times tables, okay, so if you do 12, 24, 36, 48, and then 60, do the same thing for 30. The first number that they both go into is indeed 60. So that one is satisfied, and they're both bigger than 6. So definitely correct. Quite a nice question, that one. Good. Question 20. Let's check we are still recording. We are. Perfect. Good. Question number 20. This is a fair 5-sided spinner. Okay. Kiara spins the spinner twice and records the product, which means that you're multiplying your numbers together of the two scores. Complete the table. So you can see here you've got the first spin, you've got 1, 2, 2, 3, 4, which are the numbers on your spinner, and you've got the second spin over here. And you multiply the two scores together to give you your score. So like here, 1 times 1 gives you 1, 1 times 2 will give you 2, 1 times 2, 2, 3, and then 4. 2 times 1 would give you 2, 2 times 2 would give you 4. That's already done for you. And then you've got 6, then you've got 8 over here. You then got 2, 4, 4, 6, and then 8, 3, 6, 6, 9, and then 12. You then got 4, 8, 8. 4 times by 4 gives you 16. That's done. We've completed the table. Good. I think I've missed out a question, haven't I? I'm not sure. Let's move on. No, I haven't. Right, find the probability that the product is a multiple of 3. This just means, right, you want a number in the 3 times table. So 3, 6, 9, 12, 15, 18 is above what we've already got on the thing. So we're just looking out for these numbers. You've got a 3, you've got a 6, you've got a 6, you've got a 6 and a 6 and a 9 and a 12. These are all multiples of 3, and you've got a 12. So that is going to be, you've got 1, 2, 3, 4, 5, 6, 7, 8. I've missed out one, haven't I? Have I missed out one? Yeah, this one over here. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers that are a multiple of 3. So 9 out of probability is always out of the total. And you've got 25 different scores in total because you've got 5 here and 5 here. Times them together, you've got 25 different options in total. So 9 over 25 is your answer. Good. Part B, Chiara makes a different 5-sided spinner. Okay. Chiara says that the probability that the product, again, timesing, is negative, okay, is 0.48. Write the numbers on the spinner below so that Chiara's statement is correct. Actually, this is quite a difficult question. Let's have a look at this. So, well, again, if you're spinning the 5-sided spinner and you're doing it twice again, let's just construct a bit of a table to see what is going on a bit more clearly. So we've got this again, and again we've got this, and we are again looking at timesing your numbers. Now the thing is here, you're doing this 25 times again because you're going to have 5 numbers here and 5 numbers here. There's going to be 25, like the previous one. There's going to be 25 different outcomes in total. Now this is kind of like saying that 48% of them, 0.48 out of the 25, must be a negative number. So if we go and do 0.48 and we multiply it by 25, that will tell us how many of the numbers have to be negative. Because like if you want to find this proportion of 25, you times them together, and that will give you 12, I believe. It does, yeah. Which means, right, so that's going to be, you want to have 12 negative numbers, which means there must be 13 numbers that are going to have to be positive, because 12 and 13 gives you that 25 in total. Okay, what I'm thinking here is that 12 and 13, it's a fairly 50-50 split. So I'm going to kind of assume that maybe if you kind of alternate your numbers, like if you go for 1 and then you go for -2, then you go for +3 and -4, and then you go for +5 and do the same thing down here, probably you're going to be getting pretty close to an even split. Now let's just go and finish off the table a little bit, and let's just go and check this. Maybe there's a quick way to do this, but this is a pretty sound way of doing this. It might not work the first time. I might have to alter some of my numbers, but let's at least try this one to begin with. There we go, bam, bam, and then bam. Okay, so again, if we go and do like 1 times 1, then 1 times by -2, and also just note, well, 1 times 1 is going to give you 1. 1 times -2 is -2. 1 times 3 gives you 3. 1 by -4 is -4. 1 by 5 gives you 5. -2 by 1 gives you -2. Now, if you multiply a negative with a negative, you get a positive, so +4. -2 times by a positive is going to give you -6. 2 negatives, +8, and then -10. That's going to be 3. -6, 3 by 3 gives you 9. 3 by -4 gives you -12, and then 15. -4 is going to go here, +8, 2 negatives, -12, +16, and then it's going to be -20, and then it's going to be 5, -10, 15, -20, and then 25. And that's just C. Right, we're trying to get 12 of these numbers here to be negative, and let's count how many we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, 11, 12. It worked out first time. Now that was a little bit lucky, but because I recognised that you've got a roughly even split here of positive and negative numbers, I kind of thought, well, let's just alternate your numbers here because you're going to get roughly an even split. Okay, and if I start off with a positive number, okay, there's 3 positive numbers here and 2 negative numbers here. So it's worked out nicely. So my numbers I could go for here, I've gone for 1, -2, 3, -4, and then 5. But to be honest, as long as you've got 2 negatives with 3 positive, you're going to be good to go. Okay, question 21a. You've got to complete the table of values for this quadratic. They've done the first ones for you. You've just got to go and find the y value here. So it's saying when x is equal to 4, you put it into this equation to get y. So when x is equal to 4, you put it into your equation y, which is going to be equal to, so y equals to x squared, x is 4, so 4 squared, take away 2 times your x value, which again is 4, so 4. Now, y is going to be equal to 4 squared is 4 times 4, which is 16. And then 2 times 4 is 8, but it's negative, so minus 8. 16 take away, it gives you 8. That goes in here. Done. Part B, draw the graph of this between -1 and 4, so between this and this. Now, hopefully we might recognise that this is a quadratic. The highest power is a square, which means you're going to have a shape of a graph that looks like this. And important just to recognise that basically these points here, they are just coordinates, okay? Because we know that a coordinate is always the x first and then the y. So like the first one, you've got an x coordinate of -1, a y of 3. So you've got -1 and then 3. Then you've got 0 and then 0. You've then got 1 minus 1, so on and so forth. Sorry, which would be 1 and then -1. Yeah, so you just go and plot these coordinates onto the grid. Let's go and do this. So the first one, and we've got -1, 3, which is going to be over here. We've then got 0, 0. We've then got 1, -1. 2, 0, 3, 3, which is about here. And then 4, 8 is going to be here. And then you just draw a smooth curve, because it's not a straight line, so it's going to be a curve. It's going to be a freehand curve as best you can going through the points. Of course, it's a little bit tricky on this, but actually this is not too bad. There we go, that's pretty good actually. So that is it. I've done part B. Good. Now part C, use your graph to solve this here. Now often they would put x squared take away 2x is equal to 0. Often that is what they would do. And if that was the case, you would just read where your curve, it cuts through the x-axis. So it would be this point here and this point here. But this one is saying where it goes through the point 2. So to do this, you have to draw in a straight line using a ruler, going through the point 2. Let's do that a bit more accurately. Like, no, that's not very good either. Going through the point 2, there we go. And you want to go down and find your two solutions here and here. And it's going to be an estimate because, you know, it's a freehand curve. You've got to estimate it as best you can. So to me, this looks about minus 0.7, I would say. So 21a. Yeah, look, you can have a range of values. I'm going to go for, that's about negative 0.7. So you can write this as x is approximately equal to minus 0.7. Again, this will change. That can vary a little bit. And this one here is about 2.6, I would say. Okay, 2.6. So there we go. And x can approximately be equal to 2.6. But you've got a range of values here. You know, that could be, the mark scheme has some error, but that's what I've got. So there we go. Question 22. Is this the last question? It is. Wow. Okay. Question 22. Now, these look horrific, these questions, but often, right, it's just spotting what the question is. I'm not even reading this stuff down here. It's probably going to be to do with some sort of volume. You've got a cuboid, you've got a cylinder. It could be something to do with density, and it is, because you've been given density down here. Let's read it. You've got the sculpture is formed by a cylinder, which is this shape at the top. That's a cylinder resting on top of a cuboid. This here is the cuboid. The cylinder has a radius of 45. That is just telling us that this length, so like from the center to here, this has got a length of 45, okay, centimeters, and a height of 80, which you can see on the diagram. The cuboid measures 90 by 150, which you can see. The sculpture is made of granite, so the whole of this thing here is made of granite. The granite has a density of this. Okay, granite density of this. Calculate the total mass of the sculpture. Again, a bit like the question on population density. Just work out what you can work out to begin with. But pretty key here, right? You've been given mass and density. This is all to do with the formula. Density is equal to mass over volume. Okay, so we need to know this formula, so we can go and say that density, okay, so there we go, density is equal to mass m over the volume. Okay, now if we go and consider the cylinder first of all, let's go and do the cylinder. Let's go and call it shape 1. Let's go and call this one shape 2. So for shape 1, which is the cylinder, okay, we know that the cylinder, what can we get from this? Cylinder has a radius of this. Okay, we know that the density for both of these, right, because they're both granite, is this. We can go and see that, say straight away that the density must be equal to 2.7 grams per cm cubed. We can go and get the volume, because the volume of a cylinder is the area of the cross section, which is the circle, and you times it by the height. Okay, so the volume is going to be the circular face, and you times it by the height. So that's going to be, to get the area of a circle, okay, that is pi times the radius squared, and you times it by the height, okay, because it's a prism, and that's going to be equal to 80. Now, we can go and say that the volume is going to be equal to pi times the radius, we know is 45, so pi times by 45 squared, and times that by 80. So you could just go and put this into your calculator now. So let's go and do this. I will show you how I would type this in. So literally, calculator up here, I'm just going to go and type in shift pi times 45 squared. It's going to be a huge number times by 80. There we go. We get this as a decimal. We get this pretty enormous number. Okay, but you're going to see later we've got to probably convert it into a different unit, but we'll just go through with this. So 50 8938 8938. I'm going to leave it as that because actually you've got a lot of zeros there, so that's fine. That's the volume in centimeters cubed. So now we can go, we've got the density, we've got the volume, we can go and get the mass, okay? Because we are trying to get the total mass of everything. So the mass, M, is going to be equal to, using our formula, okay, put your finger over it, density times by the volume. So we can go and now multiply the density by the volume and say that the mass is equal to density, which is 2.7. Just check you've got the same units. You've got cm cubed, you're going to be good. Times by this huge number, 508,938. The mass is going to be equal to, let's go and times this now, times this number by 2.7, and you get this even bigger number, 137,432.627 in grams. Okay, but notice at the end you want the question to be in tons, but this is fine for the time being. So this is the mass of the cylinder to begin with. Okay, it's shape 1, and let's just highlight this so we can refer to it later. Now let's go and consider shape 2, which is the cuboid, doing a very similar thing. Okay, we know that the density, because they're both granite, must be the same, must be equal to 2.7 G per cm cubed. We can get the volume, and the volume of a cuboid is nice and easy. You just go and times all of your lengths together. So you just go and do 90, times it by 90, and times it by 150. So the volume must be equal to, whack it into your calculator, so 90 times 90 times 150, and we get another pretty enormous number, 121,500. Okay, and it's going to have to be, because you're doing centimeters times by centimeters times by centimeters, it's going to be cm cubed. Now again, we want to go and get the mass of everything, so we can go and get the mass of the cuboid. So the m, again, is going to be the same formula. Put your finger over it, d times v, density times by the volume. So mass is going to be equal to your density, which is 2.7, times by the volume, which is 121,500, and that's going to be equal to, go and times this by 2.7, enter it, and we get this pretty enormous number, which I'm actually going to go and write below it. So m is going to be equal to 328,0500. So that's the mass of the cuboid. So now we can go and say that the total the total mass. Okay, so the total, let's do it in blue. The total is going to be the mass of the cylinder, which was 1374132.627. Add the mass of the cuboid, which is 3280500. That gives you a total. So we're going to go and take this number, and we're just going to go and add on that 1374132.627, and we get this number here, which is 632.627. Now, actually, at this point, I'm going to go and round this. I'm going to round this to up to a 3 because of that 6. So I'm going to go and put a 3 here. And this is, importantly, right, this is actually in grams, both of these currently. So this is currently in grams because everything so far has been grams, grams. So that's got to be grams. That was grams. That's got to be grams. Now, you want this to be in tons, okay? So this is a gram, sorry. And let's do that in blue. So we're kind of getting pretty close now. One more little thing to do. Now, what I would do first of all is I know that, let's do it over here. We know that 1,000 grams is equal to 1 kilogram. So I can divide this by 1,000 to get it into kilograms, which isn't tons, but we're going to be getting closer. So I can go and divide this by 1,000 to get it into kilograms. Now this number, if I go and divide this by 1,000, we get this, which is equal to, sorry, let's get the calculator a bit more in a better position. So we're going to be getting 4654. You know what, let's keep in the decimal place to 5.633, and this is now in kilograms. Right, you want tons, and then finally you need to know that you've got 1,000 kilograms is equal to 1 ton. So you've got to actually go and divide by 1,000 again because you've got kilograms and you want it to be as a ton. So divide this number again. I'll go and press divide by 1,000 again, and you get this. Okay, so your final answer, hopefully quite a big question, this is going to be 4 point, let's just go for 65 to 2 decimal places. There we go, and that is correct. We've got it into tons. Okay, so you have to go and divide by 1,000 twice in the end there. And that is it. A lovely question to finish up with. Okay, hopefully that was useful. Of course, you can kind of fast rewind it and go back to anything that you need to. But that is it for this video. And of course, you can comment any questions you have. We've got intervention, so you can come and see me with any questions. But thank you for watching.